Hi everyone. In today's class, we'll be doing one of the most important topics of quantitative aptitude of CAT, which is geometry. You can expect questions ranging from 2 to even 3 questions in our CAT examination. So, let's start. Okay, so in today's class, we'll be covering the following topics, starting from polygons, triangles, equilateral triangle, isosceles triangle, right angle triangle, some important terms and theorems related to triangle, then quadrilaterals, types of quadrilaterals, hexagons, circles, properties of circles, theorems, and finally, the most important tips and tricks related to geometry. So, let's start. Okay. So a polygon is any flat shape with three or more sides. So basically a polygon with three sides will be a triangle, with four sides will be a quadrilateral, with five sides will be a pentagon, six sides will be a hexagon, and so on. Like seven sides will be septagon, eight sides octagon, and so on. So there are some important properties which we'll be using in CAT examination related to polygons. Let's see one by one. So the first property is sum of interior angles of a polygon, right? So let's say a polygon of five sides, which is a pentagon. Let's draw here. This is a pentagon, right? So when we say about interior angles, I'm referring to this angle plus this angle plus this angle plus this angle plus this angle. So there is a simple formula to find the sum of all interior angles of a polygon, which is 2n minus 4 into 90 degrees. So in this case, n is the number of sides. So the answer will be, in case of pentagon, the sum of interior angles of a pentagon will be 2 into 5 minus 4 into 90 degree, which is 540 degrees, right? There is one more property of a polygon, sum of exterior angles of a polygon. Right. Now, this is a very logical thing to visualize actually. Say any polygon is there, and by exterior angle, I mean you just have to extend all its sides like this. And I am talking about this angle plus this angle plus this angle plus this angle plus this angle. If you will see all the exterior angles, this plus this plus this plus this plus this will be always 360 degrees, right? One more trick is there. So it's rather a property as well. So if we are given a measure of an interior angle or exterior angle, and we have to determine what are the number of sides of a polygon. For example, if say interior angle of a polygon is 60 degrees, find number of sides. So in order to solve this type of question, we have to be aware of one simple property. If you see clearly, here the interior angle and the exterior angle lie on a straight line. So interior angle plus exterior angle of a polygon is equals to 180 degrees. So in this question, if we are given that the interior angle of a polygon is 60 degrees, therefore exterior angle will be 180 minus 60 degrees, which is nothing but 120 degrees. Now, we all know the sum of exterior angles of a polygon is 360 degrees. Therefore, if one of the exterior angle is 120 degrees, then number of sides of the polygon will be 360 degree divided by exterior angle. Note, by here the polygon means a regular polygon, means the sides are equal. So the number of sides here, the number of sides will be 360 degree divided by 120, which is 3 sides. So it's a triangle, right? There is one more property of a polygon. It is not used much, but still you should be aware of this formula. A direct question can come in CAT. So it is area of a polygon. I want to repeat all these formulas. We have assumed that the polygon is regular. That is, all the sides of the polygon are equal, right? So area of a polygon is given by ns square by 4 into cot 180 degree by n, where n is number of sides and s is length of each side. So most of us are not very much familiar or comfortable with trigonometry. At the end of this lecture, I will also help you guys with trigonometry, some basic concepts and how those values are useful while applying in CAT examination, right? So let's move on to the next topic. So what is a triangle? Triangle is any polygon with 3 sides, right? So let's draw a triangle. And let's call this triangle A, B, C. Whenever we are denoting a triangle, we use capital letters. Also, we will denote the sides with small letters. For example, side BC will be denoted as small a. This angle, opposite to side BC is capital A, so the length of the side BC will be small a. Similarly, side AC will be denoted as small b and side AB will be denoted as small c. Right? Here the interior angles are this, this and this. Sum of interior angles of a triangle will be equals to 180 degrees. You can also compare it with the formulas done in the polygon 2n minus 4 into 90 degrees, where n is 3, right? Now, there is an exterior angle property as well. So, if we extend this side BC, so this angle, which is the exterior angle, will be equal to sum of opposite two interior angles. So, in this case, this angle, let's denote it as ACD. Angle ACD will be equal to angle BAC plus angle ABC, which means this angle ACD will be equal to angle BAC plus this angle ABC, right? Now, the third property, area of triangle. There are multiple formulas related to area of triangle. In this slide, we will stick to one or two formulas related to area of triangle and we'll cover all the formulas of area of triangle at the end so that I can provide you a consolidated view of, I think 5 or 6 formulas are there. So you can apply any of the formula depending upon the requirement of the question. Here, area of triangle is equal to root under s into s minus a into s minus b into s minus c, where ABC are the length of the sides as I have already said, and S equals to semi-perimeter. What is semi-perimeter? Perimeter divided by 12. Perimeter equals to A plus B plus C divided by 2. Right? This formula is also called Heron's formula. Correct? Now, let's move on to the next property. In this property, actually, I want to show you the different types of triangles. So, let's see one by one what are the types of triangles we have. So, first type will be scalene triangle. Here, the length of three sides are unequal, which means if the sides are ABC, then A not equal to B not equal to C. Next is equilateral triangle. Here, the three sides A, B, C will be equal to each other, right? Next is isosceles triangle. Here, any two sides will be equal to each other but not equal to the third side. So, for example, here we are assuming A equals to B but not equals to C. Fourth type is a right angle triangle. Here, one of the angle will measure 90 degrees. So, in this case, we have assumed that this angle is 90 degrees. Please note 90 degree we are denoting using this square symbol, a half of a square, right? Next is acute angled triangle. Here, all angles of the triangle will be less than 90 degrees. This angle, and this angle, let's denote in then capital A, capital B, capital C. Angle A, comma angle B, and angle C will be less than 90 degrees. Then this type of triangle is called acute angle triangle. Next is obtuse angle triangle. In this type of triangle, any one of the angle will be more than 90 degrees. Here in this case, angle B is more than 90 degrees and hence triangle ABC is a obtuse angle triangle. So these are the type of triangles which you can normally see in your questions. Next is, I want to familiarize with trigonometry since we will be using some elements of trigonometry in order to fasten our problem solving. So I'll explain a very basic idea of trigonometry. Let's say this is a right angle triangle A, B, C, where angle B is 90 degrees, right? Now, there is a important line to memorize some of the terms used in trigonometry, which is some people have curly black hair but tan permanent blue, right? Just notice the first letter of each of the word. I'll come to why I wrote this line. So let's say this angle C is theta. Now we have actually six terms are there, but three are very basic: sine theta, cos theta, and tan theta, right? So sine theta will be AB by AC. Cos theta will be BC by AC. And tan theta will be AB by BC. Now you will be wondering, what is this? It's so difficult. It's not at all difficult. Let's say in this case, theta, angle C is theta. So for angle C, AB is called its perpendicular and BC is called its base and AC is hypotenuse. These are the general terms of a right angle triangle, right? Now, sine theta is AB by AC, which is nothing but perpendicular by hypotenuse, right? Similarly, for cos theta, BC by AC, cos theta equals to base by hypotenuse, right? And tan theta equals to AB by BC is perpendicular by base. So I think most of you have got this logic now. Some people have S stands for sine theta. People have perpendicular by hypotenuse. Curly black hair, cos theta equal to base by hypotenuse, right? But tan permanent blue, tan theta equals to perpendicular by base. So this line can help you in determining what's the formula for these three terms used in trigonometry, right? Now, there is a value chart of various values of sine theta, cos theta, and tan theta. I'll draw here 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Right? Here is sine theta, cos theta, tan theta. Let's see one by one. Right? So the values have been derived as sine theta at 0 degree means these are the values of theta. The sine 0 is 0, sine 30 is 1 by 2, sine 45 degree is 1 by root 2, sine 60 degree is root 3 by 2, sine 90 is 1. For cos theta, just reverse the first line. So it will be sine cos 0 will be 1, cos 30 degree will be root 3 by 2, cos 45 degree will be 1 by root 2, cos 60 degree will be 1 by 2, cos 90 degree will be 0. For tan theta, if you will see in our derivation, tan theta equal to perpendicular by base, this can also be written as sine theta by cos theta. Since sine theta is equal to perpendicular by hypotenuse, cos theta is base by hypotenuse. So if we divide sine theta by cos theta, we will get perpendicular by base, right? So tan theta, for example, tan 0 will be 0 divided by 1, which is 0. Tan 30 degree will be 1 by root 3. Tan 45 degree will be 1, tan 60 degree will be root 3, tan 90 degree will be infinity. Super clear? In this table, you just have to remember sin theta का values. उसके बाद cos theta अपने आप निकल जाएगा, just reverse the order. Tan theta का just divide sin theta by cos theta. Entire table आपका याद रहेगा. I request you to please memorize this values. Sin theta values हो जाएगा because आपको sums crack करने में ये super helpful रहेंगे, right? So this is a basic trigonometry ka chart which can help you in solving plenty of questions in geometry. Okay, so after types of triangles and trigonometry, the next property we'll be learning is about congruency of triangles. So let's say there are two triangles, triangle ABC and triangle PQR. Right. If I say triangle ABC is congruent to triangle PQR, I am referring to it as the length of each side is equal to the other side of the triangle, corresponding side of the triangle. For example, here if ABC is congruent to PQR, then AB equals to PQ, BC equals to QR, and AC equals to PR. Not only this, the angles are also same. Angle A equal to angle P, angle B equal to angle Q, and angle C equals to angle R. Right? So this is the denotion of congruent triangles, and this is the property of congruent triangles. Corresponding sides and angles are same to each other. Right? Next is similar triangles. So again, let's say there is a triangle ABC and there is one more triangle DEF. Right? So if I say triangle ABC is similar to triangle DEF, then I imply here as AB by DE equals to BC by EF equals to AC by DF. Means the corresponding sides are proportional to each other. This is the sign used for similar triangles. There are some tests used to determine whether two triangles are similar or not. So the first test is angle similarity. So in angle similarity, we will see whether the angles are equal to each other, all three angles. So angle A equals to angle D, angle B equals to angle E, and angle C equals to angle F. Then we can say that the two triangles are similar to each other. Note, this does not necessarily imply that the two triangles will be congruent to each other. Next is side similarity. If AB by DE equals to BC by EF equals to AC by DF, then triangle ABC and triangle DEF will be similar to each other. Next is side similarity. If the ratio of two sides of the two triangles and the angle between them are equal, then the two triangles are similar. For example, here if we'll say AB by DE equals to AC by DF, and the angle between them, which is angle A equals to angle D, then we can say that the two triangles are similar, right? So there are some more properties after you determine that two triangles are similar. So I'll write here as 0.6 only. Yeah. So properties of similar triangle. This is the continuation of the previous topic. So the properties of similar triangle will be, once you determine triangle ABC is similar to triangle DEF, then you can say the ratio of sides equal to ratio of its medians equal to ratio of angle bisectors and so on. What is median? What is angle bisector? So a median is a line which is drawn from one of its fixed point of a triangle to the other side such that it bisects the other side. Bisect means it divides the other side into two equal parts. So for example, in this triangle ABC, AD is a median which divides side BC into two equal parts, which is BD equals to CD. Angle bisector is a line which bisects an angle instead of a side. So for example, again, this is a triangle ABC and AP is the angle bisector, then angle BAP equals to angle PAC, right? So this is an important property which we'll use sometimes. Next is area of triangle ABC divided by area of triangle DEF will be equal to the square of the corresponding sides ka ratio, that is AB square by DE square equals to BC square by EF square equals to AC square by DF square, right? So these two are some properties of similar triangles. So in geometry, we'll be having around 3 videos in the concept class. So the next 2 videos will be rolling out soon. I hope you like today's class. So please like, share and subscribe my channel and stay tuned. Have a great day ahead.